Hi everyone, I'm Fulgurance from the ISM project. So if some of you know already, on GitHub there is a repository called ISM, so Ingenius System Manager. So basically it's a project I start like from 2020, so over 4 years now. Time go fast. And finally I start to make a video about it to show how it works. So sorry for the waiting time, thank you for your patience, to be honest. It's just I have so much work to do. I mean my job and a part of my job, because this kind of tool is not something you make in 5 minutes. So what is exactly, so I'm not going to explain it deeper, because the purpose of this video is to show you practically how it works actually. So I'm not gonna make a full video of technical explanation. Basically, to make it simple, so this software is open source on a GPL license, made with the language Crystal. So I use multiple practical size from Crystal, because I use the interpreter part and the compiler part of Crystal in my project. I feel as well it's quite handy because the language is quite simple, it's easy to read. So I wanted as well my code simple to read, even for a beginner. Even it's an advanced tool, but I mean the code is quite easy to read, and it has the performance of a compiled language like the C language. So basically it brings all of the best pieces of the programming I like. So the goal of ISM basically is to go a bit more deeper than some Linux project like Gentoo Linux, if you know. Gentoo go quite deeper already, but the goal of ISM is you can build basically a cross toolchain completely from scratch. So you just need to indicate to ISM where is the partition, and you start to compile everything basically from completely zero, and ISM know how to handle it. So I'm not gonna take much of your time, and I will show you now how the project work. Let's go. So as you can see, we are on the website with the guide, and we are running a live CD with Ubuntu. So actually the hard disk is completely empty, it's raw. So you need first to start to make sure you have some few important tools like Crystal, Mason, Git and stuff like that. And we will start to set up a good environment with the current user. So you have to start to copy this code in the bash profile to set up the environment, because the first part need to be installed as a normal user. You need as well to set up a few global variables in the bash rc. Sorry for my English sometimes. My French accent is quite strong. So the same, you just copy paste basically. And next we just need to make sure some file we don't give some issue during the installation. So just follow basically the guide at the beginning. And then you need to source the bash profile we just made before to get the environment. And then we will start to make our mount point for the new system. So I select MNT ISM, but you can choose whatever you want. I mean, if you know already how it works a bit. And make sure you have the right of the current user as I show. So in this live CD you have to set up to the user and group Kubuntu for MN10 and MNT and ISM recursively, remember that. Now we will start to clone the repository, so basically the code of my project. We'll move it to user share, and we will start to compile it and set the proper right as well, so that at the moment it should be with the current user as well. So Kubuntu again. So you can start from any other live CD. I mean, if it's Linux, normally it's okay, but anyway. But I think it's a good base because the Debian based distribution are quite good. So now if you install the tool already I mentioned before, so you start to compile it with the compiler Crystal. You noticed as well I passed the option release, so I recommend you to use that because the program will be much faster even to calculate the dependencies, so it's highly recommended, except if you like to waste your time, but it's up to you. And then we will copy the binary into user bin to use it. So it will, ISM will run in the live CD basically at the beginning. After we will be in the system, but not at the moment because there is nothing at the moment. So I'm just waiting for the compilation time. Yep. And we copy paste. So now from this step, as I mentioned in the guide, you have to start to format your partition. So basically we have a raw disk located at dev SDA. You can notice I increase a bit the window size because with the current resolution sometimes it's too short to open CG disk. So I made something very simple. I have a 500 megabyte of for the UEFI partition and the rest for the root partition. So it's a very simple partition. And then we need to format it. So in FAT32 for dev SDA1 and SDA2 I choose BTRFS, but you can choose whatever you want. I mean, if you are quite used already to do it by yourself. And then we start to mount this partition. So you mount first the root partition on MNT ISM. After you mount it, you need to make sure it's with the current user rights. So you need again to change it because when you perform a sudo mount, it's changed to root. So you need to set up to the current user again. So with the command shown. And then I will make the directory we need for the UEFI partition. So put UEFI. And then we can mount it. That one you don't change the right. You don't need it. Yep. So now all of the minimal system is mounted. So it's still empty, but we have the base, I will say. We have all of the partition we need. So now we will make the minimal directories we need for the project. So ISM need two directory, etc ISM and var ISM. So the same, you need to set up the proper right with the current user at the beginning for that one too. So just follow the guide. Normally it's not difficult with the guide. And then we will disable the secure mode. Normally this mode should not be disabled, but when we start to make the cross toolchain we need to disable it, because if you don't disable it, some function can't be used basically without the root rights. But at this moment we need to perform some action without the root rights, so no choice. Now we show to ISM where is the root partition, and I set up how many cores I want to use from the virtual processor. So actually I set up one from the CH root and from the current system. And now, as I show with the cursor, we will synchronize all of the repositories basically. I call that ports in my project. So basically it's a Git repository. So there is quite a few ones. If I remember, it's like 45. Let's see. After the synchronization. So actually we just open the port and now we synchronize it. Yeah. I had fun with this animation as well, as you can notice. I like to make things nice. So yeah, if I remember, it's like around 45 repositories now. It starts to be quite a lot. I mean, I'm quite close to 800 available softwares now, so it's quite a huge work. Yeah. And almost up to date for most of them. Yeah, 45. So now we will start to install the very first base of the cross toolchain, the minimal requirement to do a CH root basically. So as you can see, I don't copy the first command just to show you something. If I want to install CH root base now, I will have a problem basically, but to show you how ISM handles the problems as well. If I run now, it shows, oh, I can't install this software because you didn't select a dependency, basically. So basically the virtual package kernel asks you to select which kernel you want to use. So you just need to tell ISM which one you want to install. So you just need to do ISM software kernel, is the virtual name of the package, select dependency, and actually I would like to use the SE Linux kernel source, so we go for that one. And now if you perform again the dependency calculation, you see now it know how it works. So as you can see, we retrieve the SE Linux kernel source we select, and some software have different build phase. So basically ISM show there is some software, they have different step of building process basically. So we'll start the cross toolchain compilation now. So let's see you at the next step. So now the chroot base is installed, as you can see. So you have a small reports about how many directories on how much memory it take. So after that we start to continue to build the very first base, because the system is not fully installed. We still need to finish to build the cross toolchain. So it will install very vital groups and users for the system basically, and make a few important directories. Nothing big at this step, but important still. So it's quite fast because all of the packages are virtual actually, almost. So yep, and now we'll start to mount a minimal virtual file system for the kernel to make sure the chroot will work properly after. So just copy paste again. Copy paste, copy paste, copy paste. Basically it's that, yeah. And we enable the installation by chroot now, because ISM now can perform installation by chroot. And after, just copy the network details to make sure you have network in the chroot, or the installation will not work. And now we can enable again the secure mode. So we can start to use the root user now to do the other installation process. So now we'll finish to install the system base, as you can see the name. So it starts to calculate dependencies again. So it's like about 90 package, if I remember, 95. Yeah, something like that. I start to lose my memory. 95, yeah, so I don't start to lose my memory. Pressuring. So as you can see, it continues to know which step he needs to be built system based as is at the pass 3, sorry. So let's start again and we'll go to the next step. I just skip this part because if I show you the compilation, it's quite long. See you. And here we are. So now we have the full very first base of our system. We don't need to make any toolchain basically. So you have a very small first base basically. So now we will start to enable some specific software from the system base. Basically system base, if you want to know, is composed of different layers, and you can choose every component of your system. So if you want window manager, if you want a desktop environment or not, etc, etc. So we just set up that and we select which file system we will use as well. So it's like profile in Gen 2, but I mean you don't need to go by profile basically. You set your own profile in very easy way. As you can see, you just need to select some dependency. For example, system configuration is the top layer, so you can select if you need a bootloader, a kernel, normally yes, but I mean you can really select every single piece of your system basically. So it's really made depend of your needs there. So we select the DOSFS tool and PTRFS progs because we need it for the partition we use, so for UEFI and BTRFS for roots. And now we'll start to install the profile. So ISM software install, system configuration. So because we install the Plasma desktop environments, dependency calculation will be longer because we start from scratch from very beginning. So it's like around 45 software if I remember. So it's a bit longer, yeah. So you will see during the video later when I will cut and when you will come back, the number of software installed doesn't match with the beginning. It's normally just I had to fix a few bugs. This project is still in development, so it starts to be quite stable. I used to use my system on my own laptop, so it's quite stable, but at some point, sometimes I have to face some compilation issue, and compilation issue can be quite tricky. So, but no worries, there is no trick, it works. It's not magic. So if you wonder, actually we are in a virtual box. I recommend you to have quite a lot of RAM, because especially when you perform compilation, it takes quite a lot of memory. But if you have quite a powerful laptop, it's fine. A computer will be probably better, but so as I say, it's quite a bit longer. Yep, so 445 software. So you can see some options are enabled by default, or others are enabled because some software need it. So and it take account of the some profile, something we select from the profile as well. So yeah. So by default, actually, I don't use systemd. I use OpenRC. I plan probably later to integrate as well systemd. Just I prefer that one at the moment. So now we can start the installation. So I see you later. And now the system is completely installed. I will say almost, but we are pretty close now. So all of the components for the Plasma desktop is installed. We have the bootloader, etc. Now we will install some dependencies needed for ISM. So again, I will do a very short skip because we need to wait for the compilation time again, and I will see you on the next video. So now Git and Crystal are installed, so we have what we need. So we'll start to mount the UEFI partition now, because we need it to boot after. And now we can start to perform a chroot. So we'll be in the system and see if it works or explodes. It worked. Normally it works. It was a headache, but now it works. So now we clone again ISM, but inside the system we generate now. So it's a bit longer inside the chroot. I never know why, but it's like that. It's life. And then, as you can see after, basically we'll install a very few tools just to make sure we can save the system and perform minimal administration process, like the sudo, for example. It's very important. Cronny for the time. Nano, if we want to edit some text files when we are in a TTI, so some vital things basically. So again, after this installation, I will skip the building process, and I will see you again at the next step. So now the last two are installed. So we'll start to generate the file etc/fstab. If you know that file, basically explain to the system how have to be mounted the file system when the system starts. So it's vital. If you don't do this file, you will have kernel panic basically. So you have to make it. So actually you have only one partition, so it's quite easy. Now we'll set the host name. So you can set whatever you want. I choose for this one VirtualBox ISM because it's for the demonstration. So yeah, so up to you at this step. And after we'll just enable minimal services we need with OpenRC. So just copy paste again. Basically it's what you need to run the Plasma desktop environment. And now we'll do the most funny part, the part everyone like. We'll compile the kernel. Nope. I like this step, but it's still not my favorite and probably not yours as well. So I accelerate this part to don't make you suffer too much. And after there is the kernel compilation, so I will leave you with the accelerate video and I see you just in a bit. So now the Linux kernel is compiled, so we'll start to generate the UEFI partition with grub. So just run this command. If you used to install some Linux system from scratch, you know already what is it exactly. Now we need to set up grub as well to know how to boot. So we need to show to grub where is the root partition basically. So at this step I just copy paste because I make it easy, and I disable SC Linux because it's can be quite sensitive at the time if you don't know SC Linux. Now we copy just the needed files we need from the kernel. There is a few optional steps if you want an encrypted installation, but we're not gonna do that for this demonstration. And now we generate the grub. And now we just need to make a normal user to log in and to see if the system works basically. So I choose my pseudonym Fulgurance with the most important system groups. So will for sudo, video for SDDM and the system, and plug that as well. And now we have to select SDDM as the display manager. So basically when the computer will start, it will start the program SDDM, and SDDM will be in charge to charge the desktop environment after. So we choose that one. So fine, after I did that, basically we are done. You have just to pray it work now. It worked. So now you just need to exit from the chroot. We don't need to perform a task anymore. And after it's better to unmount properly the file system, so you unmount in recursive mode MNT ISM, so where you mount everything. And now we are ready to reboot. So now the VM restarts. So as you can see now, grub is loading ISM. The kernel starts, so it's good. OpenRC starts, so the init system start as well. We can see all of the services run properly, so no issues. There is just a small issues with WPA supplicant. It worked, but there is an error message at the beginning. I still have to fix that, but it's harmless to be honest. And now let's see if it login on SDDM. So it's the last one of the last version of Plasma. It's Plasma 6, 6.7.0 if I remember. So now just put the password and let's see if we can log in on Wayland. So by default it's Wayland now. Xorg will disappear after, so no point I make support for Xorg. I mean, you can run some compatibility layer with Xorg, of course, but Xorg server will disappear after in the future. So as you can see, the system works fine. So we can see the info center. So you can set up the name of your system. So actually it's set at unknown, but as you can see, the system set it as unknown. So we are under Plasma 6, as I said. We are running the kernel 6.11 on Wayland, so everything works fine. And we can try as well the console and see if the user works properly with sudo. So we can try, for example, to install Firefox, and let's see what's happened. Yep, it just did notice we need to select a dependency, but nothing to worry about. We can try with another one, LibreOffice, for example. Yeah, so everything worked fine. Well done. And this is the end of this video. I hope you really enjoyed to see this project in action, even it's still in development. I will be very happy to have people to try the project and report some bugs as well. I will need help as well to do the website, because basically I want to start my Linux distribution. Don't hesitate as well to leave stars or a like on the video. It will help a lot, so any contribution, to be honest. But thank you very much to see this video, and see you next time.